Hello everyone, welcome to another video of mine, and in this video we will be solving question number 10 of October November paper 33. So this is the question. The question is related to the topic of trigonometry as well as integration. The most of the question is related to the integration part. So this is a very important question if you ask me, and like it's very necessary to practice these sorts of questions. So in this question, it is given that use the substitution u is equal to tan x to show that for n is not equal to minus 1. So we have to show that this, the left hand side is equal to this. Like the integral of the left hand side will give us this, and we have to show this. And this has to be done with the help of trigonometry substitution, integration by trigonometric substitution. So we are going to use this substitution over here. So at first, so by this substitution we mean over here it is u is equal to 10x. So this is simply going to become u n plus 2 plus un. But the problem is the dx. How are we going to remove the dx? Like we need to have dx in terms of du. So we have to do that right now. The rest of the u's we have to remove this dx over here. So we know that u is equal to 10x. It is given in the question. So we are going to differentiate with respect to x. So this is du over dx. And we already know that the first derivative of tan x is sec x. We already know this from the differentiation. You should be knowing this. It's that d tan x over dx is equal to sec square x. So I simplify things. So I'm also going to show you why it is equal to sec square x. So what happens is tan x is equal to sin x over cos x. And as you can see that sin x over cos x is in the quotient rule. So we can simply use the quotient rule to derivate it over here. Just write me that d over dx over here. So we're going to use the quotient rule over here. So we're going to get cos x, and the derivative of sin x is cos x, right? Minus, so we're going to have sin x as it is, and the derivative of cos x is minus sin x, and then we have cos square x in the denominator. I'm sorry, I know that I do simplify things a lot, so simply cos square x. It's maths, you should know where something is coming from. Sin x plus sin square x over cos square x. We know that from our paper 1, from our AS level, that cos square x plus sin square x is equal to 1. So this is going to be 1 over cos square x. So this is going to be equal to sec square x. So this is from where we get the derivative of tan x is at sec square x. I hope you understood all of these steps. So yes, hooray for me. So we got that sec square x. Okay, now we know that du, I'm going to bring sec square x over here. Sec square x is equal to dx. Now one more thing, we also know that 1 plus tan square x is equal to sec square x. We know this from our trigonometry topic, sec square x. And if you ask me from where do we get this, so again I'm going to do the same thing. We know that tan square x is 1 over 1 plus sin square over cos square. And we again know that we're going to take the LCM, and we're going to get cos square x plus sin square x. We know that cos square x plus sin square x is equal to 1 over cos square x is equal to sec square x. So from here we get this. So you should be knowing all of these things. I'm just showing you like to tell what from where we are getting everything, and I hope you understand each and every step that we are doing over here. And this also gives us the time to look back from where do we are getting things. So simply I'm going to do this du 1 plus tan square x is equal to dx. Now we know that what is tan x equal to. Tan x in the question it's given the tan x is equal to u. So I'm going to simply substitute tan x as u over here. So we're going to get du 1 plus u square is equal to dx. So now we have gotten dx in terms of u. So we can also simply substitute the value of dx in the equation. Now we are going to have all of the variables in terms of u, which is a good thing, which is what we wanted, because otherwise we wouldn't have integrated it if we wouldn't have been able to integrate it if even one term wasn't in terms of u. So we got it du 1 plus u square. And one more thing that you can ask me is that how do we know that if we have to use this trigonometric expression or not, like converting sec square x into 1 plus tan square x. So the reason why you will be able to catch that you have to do this step is because that is the only way you're going to get the expression in terms of u. I hope so. I hope you do understand that step. If you don't, please do let me know. So we have got dx is equal to du over 1 plus u square. So let me move to the other slide. So now one more thing, as you can see that these limits over here are for x, not for u. So we are going to be converting these limits in terms of u for u, like they can be used in the u expression. So simply we're going to do is now when x is equal to 0, when x is equal to 0, we know that u is equal to tan x. Simply we're going to substitute u is equal to tan 0, and we know that tan 0 is 0. So when x is equal to 0, u is equal to 0, and when x is pi by 4, u is equal to tan pi by 4, which is equal to 1. So when x is pi by 4, u is equal to 1. Now we have gotten, first what we did, we got the whole expression in terms of u, whole expression in terms of u, and then we got the limits also in terms of u, the limit in terms of u. I hope you are able to understand each and every part of this. So now moving forward, what we are going to do is, now we've gotten all of these things. So we simply know that our expression is this: 0, 1, un plus 2 plus un du 1 plus u square. So now we are going to have to integrate all of this. And how are we going to do that? Let's see. So we know that un plus 2 can be written as un into u2. So I can write this as un u2 now plus un du 1 plus u square. Oh, if I see over here un is going to be common, so simply take out the common. 0, 1 un u square plus 1 du 1 plus u square. Oh, just look at what happened. This and this is going to get cancelled, and I'm going to be left with is equal to 0, 1 un du. So that's what I'm left with. So now I'm going to integrate this un du. So is equal to 0, 1, sorry, is equal to, we're going to simply integrate this, like the simple integration un plus 1, and in the denominator in as well n plus 1, 0 and 1. So Let me move to the next slide, applying limits. Sorry. Applying limits. So we have u 1 plus 1 over, sorry, my bad. We're substituting in u is a variable. So 1 n plus 1 over n plus 1 minus 0 n plus 1 over n plus 1. So anything raised to power 1 is going to give us 1, and we're going to get n plus 1. This, all of this is going to become 0 because in the numerator we have 0. So you know, anything if 0 is divided by anything, we get 0. So this is 0. So henceforth we have proved that our equation, this that this equation is equal to this integrated, and we have done this through trigonometric substitution. I hope you understood it. Oh god, it took me 11 minutes to only do this part because I simplified it a lot. So now I'm going to be stepping on to the second part, and yes, so give me a moment. So moving on to the second part of the question. So the second part says that hence find the exact value of this, the A part and the B part. So it uses the word hence, which means something from the above part is going to be used over here. So this is a hint, the hence word. It is a hint in this question that something from the above part is going to be used. So the hint is that I will try to convert this expression into tan x, something like this. So immediately I'm going to get the integral, which is going to be this, and the n a value, whatever is it going to be over here, it's going to be substituted over here. So this is the hint. So I have to convert this into some expression like this. Even the b part, I have to convert it into this in order to solve it, otherwise I won't be able to solve it. So what we're going to do is, so we know that sec square x is equal to 1 plus tan square x. So we know that already. So I'm just going to simply 0 pi by 4. So we know that sec 4x is basically the same thing as sec square x over square. So I won't be writing that again, and I'm simply substituting the value. So 1 plus tan square x square minus 1 plus tan square x dx, and simply we are going to expand this by the a plus whole b square formula, which is a square plus b square plus 2ab. So this is going to become 1 plus tan 4x plus 2 tan square x, and this is going to get multiplied, minus into minus. This is going to give us minus 1, then minus 1 plus tan square x minus tan square x dx. So as we see, this one and this one is going to get cancelled, and we're going to be left with 0 and pi by 4, and then we're going to be left with tan 4x minus tan square x. Oh hey, do you note anything? You note something? I believe you do. This is going to become plus tan square x. Sorry, I made that mistake because this is plus 2 and this is minus 1. So we obviously keep the sign of the larger number, which was a very, I don't know, dumb mistake by me right now. So what do we see? Tan 4x. So tan 4x is what? 2 plus 2 simply. And we have square over here, which is the n. And n plus 2, 2 plus 2 is equal to 4. So what do we have gotten? We have gotten this expression over here. So what I can do, I can simply write this as is equal to 1 over n plus 1. and we know what is n is 2, so we are left with 1 over 2 plus 1, which is 3, so is equal to 1 over 3. So see, this is how we did this part, and it's correct actually. So I hope you understood the A part, and I would want you to pause for a minute and try to do the B part as well. It ain't that difficult. You can do it. I believe in you. So please pause for a minute and do try to do it. So hope so you did try doing B part, and I hope so you got the answer as well. But if you didn't, there ain't any issue. I'm over here and I'm going to help you in it. See, again, the main game is to convert this into this. But how are you going to do that? So you know that this is 7 plus 2, so n is 7 over here, and this is 3 plus 2. So what are you going to do is 10, 9x. So I'm going to break this down into 4. So I'm going to break this down into 10, 7x, 7x. So I'm going to break 5 10x into 10 7x plus 4 10x, 4 10 7x. So if I'm going to add this, I'm going to get 5 10 7x, but I've split it up. You're going to realize why I'm doing this. Then we have 5 10 5x. So simply I'm going to do plus 4 10 4 10, sorry my bad, 5x plus 10 5x, 10 5x. I hope so you do get the pattern by now that what's actually happening, plus 3 10x. So just let me write this 0 pi by 4 over here, and this is bracket dx. But do you see anything? Is this following a pattern? 10 9x plus 10 7x, 4 10 7x plus 4 10 5x, 10 5x plus 10 3x. Isn't it following a pattern from the part 1, from the above part that we have done, the first part? Yes, it is. See, we have 10 7x, and what is the, when we're going to integrate this, what we are going to get? We're going to get this 1 over 1 plus n, and what is going to be the n over here? 7. 7 plus 2 9. We have 5 over here. 5 plus 2 7. We have 3 over here. 3 plus 2 5. So simply it is, so simply when we are going to do this, we're going to get 1. What is the n over here? 7. 7 plus 1 plus 1. What is the n over here? 5. 5 plus 1 plus, what is the n over here? 3 plus 1. 3 plus 1. So we have 1 over 8 plus 1 over 6 plus 1 over 4. Pick up your calculator, add all of them, and you're going to get your final answer. 1 over 8 plus 1 over 6 plus 1 over 4 is 13 over 24. See, you are done with it. I hope so you understood the question, how to solve this. I know this might not be your everyday question or question you see in every other past paper, but this is a very good question. I hope so you understood it, like how to solve it, and I was like very efficiently, explain it and get out my ideas. I know that this one is a pretty long video, but you should know where things are coming from. That is the reason why I simplify things, that you should have an idea where something is coming from, and not just memorize it or ratify it and see, yeah, this is it, what it is, because we were told like this. No, you should be knowing where it is coming from, because at the end of the day, that is the maths, from where it is coming from. So please do like, share and subscribe to my channel, and if there is any particular past paper questions that you want me to solve, I would be more than happy to do that. So please do let me know, and do like, share and subscribe to my channel. Do like, share and subscribe to my channel, and do comment. See you in another video. Bye.